Cameron and Chandra, where you all at? There we are. You guys ready for this? There we go. So, I'm going to leave it to you. This is the last that you will see of me, for better or worse, for the day, night. I'm going to sign off. Man, you're the best host ever, man. I've been digging and watching. Okay. I'll tell you a little secret. Today was my birthday. I couldn't have thought of a better way to spend it than with everybody here, enjoying and learning a ton. It's a little bit of edutainment we got going on. Chandra, I think you're on mute. You might want to fix that before we get this workshop started. You might want to sort that shit out. There we go. I see, Cameron, you've got quite the collection of guitars there. Let me just... I do, man. I wish I could jam with you on this thing. Serenade. Yeah, where's your serenation happening? Sing the workshop into... they pay me to tech, so... Chandra, are you there? Your sound working? No sound for me, Chandra. No. Not yet. But in the meantime, if you have not done it, this is a great chance to fill out the feedback form. Because you know what? I would love to know if you all enjoyed this. If you had a great time, if you did not like anything, we want to hear all of it. We got sound yet? I think so, right? Yeah. Success. Fantastic. All right, I'm out of here. I'll see you guys later. Awesome. Thank you so much, Demetrios. Wow, what a great day of programs, right? Oh, for sure. I know, right? I couldn't imagine it being better. I learned a bunch. I know. What was your favorite session that we had? I don't know. It's like I'm an old database guy, so I'm always looking for that bridge between the old database world and data lakehouse world, and just making things easy. So hopefully in our demo here, we'll show folks how to make it easy. A comment. We wanted to do a full workshop. Actually, we were limited by time on this thing today. But if you're interested in seeing us do a full workshop, maybe put a comment in the chat. And we'll take that under advisement. Might be something we do in the future. Yeah, certainly. We can set something up for anyone that's interested. Yeah, just let us know. Drop a comment in, and we'll get something scheduled for all of us to get together again. All right. Sure. I'm excited to be here, everyone. Thank you for sticking around for a little bit. Brief introductions before we get started. I'm Chandra. I'm on the solutions team here at OneHouse. I want to introduce my colleague Cameron here. If you want to take a second to quickly introduce yourself. Yeah, Cameron, I work with the product marketing team. Awesome. So we're really excited to come in and show you guys a little bit about the OneHouse platform. Why the company was formed, why we built the platform, and kind of what we do. And as Cameron was mentioning, a lot of the cool work that's going on around combining databases and data lakes and making analytics and data science and machine learning and all of these really exciting things that we've talked about all day here, available for everyone. With that, why don't we get started? One of the things that we wanted to immediately start with is talking a little bit about the problems that come with building data platforms. Cameron, I know you've been in the data space for quite a few years here. I've also been working in data for the last several years, and if there's one takeaway that I've gotten from all of this is it's not easy, right? I'm sure all of us in the room here can agree, right? There's lots of challenges that come with building a data platform. It takes a long time. It can often be expensive. Take a lot of people to kind of work together and work really hard.
to get it done. Would love to hear, if anyone's got specific challenges that they encountered that they thought was really interesting and things they have to work through. Drop them in the comments too. We'd love to hear about the challenges that people out there in the community are working on solving. And the other thing is a lot of data platforms are out there and they help solve a lot of these issues around things, maybe taking time or taking a lot of resources, but oftentimes what we found is when you adopt a platform, they can kind of lock you into using maybe the formats and the compute of that platform and things like that. And so your data is kind of loaded into this platform here, and we find that it's oftentimes difficult to move your data around. You've heard a lot of exciting talks today about the open table formats and what they do to make that data open and interoperable. And at One House, we just wanted to expand on that and make those capabilities available to everyone. That brings us to kind of how One House came about and what the goal of One House is. Earlier in the day, you had a chance to hear from our founder and CEO, Vinod, who was the original creator of the Apache Hudi project, the original kind of data lakehouse project out there that was designed around making transactional data available in an open format with high update throughput capabilities. The One House platform, it's really meant to do that for everyone, right? We want to get that data available from your data sources, as Cameron's going to show you in a second here, ingested, landed on top of your open table formats, optimized once it's there, and having those tables fully managed and properly cleaned and compacted and the files all sized correctly. And also let you bring, all of the ETL, logic and the business requirements and capabilities around your transformations to the platform and being able to execute all of those really efficiently. And finally, doing all of that on top of the great openness and interoperability that we've seen come out of this lakehouse phenomenon. Where the data, once it's created, it's available for all the use cases that you might need. Whether it's BI, analytics, machine learning, data science, even vector embeddings and AI and things like that. It's kind of why the One House product was created and how we hope to deliver impact through the product. Inside of the product itself, we have several kind of core components that make up what we do as a part of the One House product. You'll see all of these components in action in our workshop here. But the first piece is around data ingestion, right? We want to make sure that, wherever your data is being created, you're able to take that data and with the click of a few buttons, get that data ingested lightning fast and landed on top of your open table formats. Once they're there, as you all probably know from experience and feel free to chime in the comments with any things that you guys have to work on around this. Once those open table formats are created, they need to be maintained and optimized, right? The tables need to be managed, and so we provided kind of an experience around getting that to happen really quickly and seamlessly. From there, we wanted to say, okay, we've got these open table formats. Our data is expressed across, Hudi, Delta, and Iceberg in the platform. Let's make that available to anyone to use and consume and really take advantage of for their use cases. So we put in the one sync inside of our catalog sync, where we're able to sync it across all the different catalogs that you might have. So the data is now available via the catalog integrations in all of these different exciting engines. And also in our most recent launch that just happened a few months ago, we have the Open Engines capability, where if you wanted to do maybe some BI analytics with Trino or some machine learning data science use cases on top of Ray, that infrastructure can be spun up quickly and seamlessly in just the clicks of a few buttons, so that you're able to do those use cases more fast, and easier on your teams from an infra perspective. This last piece is what I'm really excited to be talking about, and you'll see me in a bit here chatting about them. Is around our transformations capabilities. We found, as people are using data, and as you know, data engineers need to be able to transform the data, create specified views of their data, and have the ability to be able to perform aggregations and joins and all of these like complex queries and transformations. And so recently we launched the ability to do Spark SQL, as well as Spark Jobs directly on top of that data. Hook in whatever tools that you're doing to right now for those capabilities, whether it's through Python jobs, or maybe you're orchestrating SQL on dbt or something like that. Have those run directly on top of OneHouse. And what makes OneHouse really exciting is all of these things happen on top of a shared compute platform that's optimized for your Lakehouse workloads. We call it the OneHouse Compute Runtime. And then on top of that, for Spark and Spark SQL specific things, we have our Quanton engine that was just recently released that performs additional accelerations on top of that. So all of this runs directly on top of OCR, the OneHouse Compute Runtime, which is specifically Lakehouse optimized operations, on top of what we have for the capabilities inside the product. So you get vectorization of operations that happen on top of the Lakehouse. We've got advanced multiplexing, job scheduling, and compute management that's entirely serverless inside the platform to really maximize the compute efficiencies that you're able to get. And some of the really exciting benchmark results that we were able to get is on top of the OCR. We were able to see queries run oftentimes 30x or more faster. Write operations were able to be sped up up to 10x, and really make your platform run more efficiently. With that, I want to hand it back to Cameron to maybe talk a bit about the platform and show you guys what's going on under the hood.
Awesome, thanks, Chandra. If we could switch over to my screen, that'd be super cool. And I'm going to be showing you the OneHouse Open Data Lakehouse, at least the UI, the part that you can see. There's so much more that goes on behind the scenes, and I'm going to really focus on this demo on two things. And again, we'd love to do a full workshop with you guys, because we've actually built this whole diagram. I know this diagram looks a little overwhelming, but we actually have all this stuff running. We built it. We can't, we just don't have time to show every little piece. So we're really interested in, having a full workshop experience. But I want to really drill into, Chandra, I want to go into the speed at which people can provision, really a world-class data lakehouse implementation, and get that up and running really quickly, because that's one of the things I've noticed. And then just what it looks like to, use an open data lakehouse, have this all be open, and the different ways that you can use the data, just like you've laid out in a real practical sense. So I'm going to refer back to this diagram in a little bit, just to point out different pieces. But let's just head right on over into the OneHouse UI. And I want to start down here on the usage page. And the reason I want to do that is I want to be sure everyone understands that what we're actually provisioning, all the servers and the storage and everything, all the components of this data lakehouse are going in your cloud account, right? You own it. So here, if I click over to Amazon S3, and here we have here, let me go back, and I have some tables over here, some silver tables. If I go over here to Amazon S3, these are the S3 buckets, right, where the data is actually living. And this is in, this is in one of our cloud demo accounts. It's my login, my account. So this is data that I control. I control it. I own it. In other words, I'm not having to upload my data to a third party, to another vendor, really make a copy of it at all. So that's a huge difference, in just in how you use the one house data lakehouse and it being open than you might be used to seeing, right? And the other thing that we see here on the usage page is this OCU, this one house compute unit. And this both allows you to limit and throttle the usage of the resources within your cloud account. But we also use it as a way to bill for our management services. We have a control plane and we watch your system and we look at the metadata. We never touch your data and we don't look at your data, but we look at the metadata and we keep everything running very smoothly. We've got a bunch of guys with pagers that, are on top of that if there's, ever a hiccup, right? And so we can further then, take these OCUs and we can customize how they're allocated right across the different types of compute clusters that we support, right? And these include, see down here, managed clusters, and you could have like maybe a separate one, for different teams. Looks like I was running a bunch of queries earlier. So we have the managed clusters, we have the SQL clusters, which give you an endpoint for external tools to tap into the one house services. And then we have open engines, right, which cluster type open engines, which let you provision open source compute engines that work with your data lakehouse very easily. So now to provision new tables in the data lake, and keep in mind that all these steps could be automated through an API, right? You don't have to do any of this manually. You can go through APIs and automate the whole thing. There's basically 3 steps. And the first step is you're going to set up your metadata catalogs. And these are the things that you want to populate and keep in sync so that you can use the data with different systems and tools. So we have, different things that you can populate, including Snowflake and Databricks. But in particular, I want to point out this one here, which is one table. And this is our implementation of Apache Xtable, actually, which OneHouse created and we donated, and it's being used by several players in the industry right now. But this is what gives you access and will generate metadata for Hoodie, Delta Lake, and Iceberg, right? And this makes sure that your data can be used everywhere. We're gonna see that in just a minute. So you set up the catalogs. It's pretty simple, fill in the blanks, and then the very next thing you're going to do is define your data sources. And we have a number of data sources. As we're pretty into stream data sources, and that's because our platform uniquely is able to handle data streams and do incremental ingestion so that your data, is fresh. We try to stay away from, the overnight batch thing and keep the data coming in concurrent with whatever's going on in your business systems. But this really just involves, let's see, I can try to add a new data source. Let me just refresh this. There we go. This just really involves basically getting your credentials and the location of the data, right? And so that's a really simple fill in the blanks kind of thing, just like that. And then the very last thing you do is a stream capture. And I'm actually going to create a new stream right now. You can see that we have 4 of them running. I have 4 tables kind of in my bronze or my raw data section. And right now I'm going to just add a new stream so you can see exactly what that looks like. And I'll pick a data source here. I'm going to actually grab this from Confluent Cloud. And we have Confluent running over here. I have some messages coming in here, but we're going to create a new stream. And so what I'm going to do is I have actually something that's updating a Postgres database. And we're actually, with these steps, it's going to go out, it's going to set up Debezium, it's going to grab that data off of the Postgres database, it's going to create a Confluent topic, it's going to create the things needed. In short, it's going to create the whole data pipeline for you. This is something that would just take you days and days to set up if you were doing it manually. So I'm basically going to say I want it from Confluent Cloud CDC. I can choose, do I want it to be append only or mutable? And this is a big difference with OneHouse. Our data lake can be, can support changes very efficiently, and that's one of the big advantages of the Hoodie, table format is it can really handle updates, inserts, and deletes very efficiently. So we want to sync every minute, and here's the table we're going to grab. And I'm just going to configure this and show you some of the options. So quarantine is if you have records that don't meet validation, you can put those into a separate table so you could deal with them later. That's pretty cool. Transformations are things that are applied during ingestion. These are low-code or no-code transformations. They work on the incremental data coming in. You can see we have one applied here. It was done for us automatically, but I have a few others, and plus you can create your own. Here's one that I wrote and added to the system that does a bunch of string operations. But you can write, whatever you need here, and they can get quite robust. And then finally get down to, just basic things like, do I want to choose a validation? What's my key fields? Things like that. And then finally, where's the data going to be located? What data lake? What database does it go in? And now the catalogs I want to populate. So I'm creating this new table. And this is true even if I do schema, migrations, I add columns, I do things like that. It'll keep all this synchronized. So let's say I'm already populating glue. I'm going to also push the metadata out to Snowflake. We'll send it to Databricks. And I'm going to do that metadata format conversion into Delta Lake and Iceberg as well. And let's just give this guy a name. So we'll just call this CDC, what is this, the promotions? Yeah, promotions table. And we will get that guy going. And while that's going, let's run up and see what some data looks like that we already have. So we can see, here well, now it's 5, so it's already started to create the table, space for the table that we just provisioned. But you can see the other tables that we had streams for right here. If I click into one of these, I can look at metrics for the table and see how many rows, see a bunch of information about data coming in. Here we can clearly see the upserts, the inserts, and deletes that are happening on this table every day. This table is a little bit larger, and we can see more data coming in, and in particular, there's quite a few upserts on this table as well. So a lot of not just insert activity going on. The other thing we can see is, all the table services that are running here. So we have the cleaning, clustering, and compaction services running on this table to keep the data, organized and compact and performing well on disk, as well as the metadata sync process. So let's see, we're still waiting for this to, I know this hasn't provisioned yet, it takes a few minutes, but remember the metadata catalogs we were looking at a little bit earlier? Let's move from provisioning to showing you how we could use this data that we have here with some other tools and see how that works. So let's pop over to Databricks here, and we can see that these tables are being populated automatically. Now these are, we're not actually moving the data into Databricks, we're just putting a reference here. So everything we do is by reference, right? So we're pointing back to the one-house data. And then I can run my queries here. I can do whatever I need to do in Databricks, whether it's machine learning or whatever, using that same copy of the data that's in one-house. I don't have to move it, right? And it's all just by reference. Same in here in Snowflake, right? So here we have the tables. All these got populated automatically. I can run queries against the data over here, and it all just works. And I could do whatever I needed to do in Snowflake, again, against that same copy of the data. And you may have noticed these silver tables, that I have here. I don't have, these guys here. Well, how did those get there, right? So I've also got dbt Cloud running. And so I'm using dbt Cloud. And remember the SQL endpoint I mentioned earlier? I'm using that SQL endpoint to tap into one-house, right, and run these models in dbt to create my silver tables or my refined data lakehouse tables. And those get created, they get put right back here in one-house. And the really cool thing about this is that these also participate in all the one-house services. So they get table services, they get metadata sync. That's how it gets created here, and then the exact same tables get pushed out, to all the places that we want to see it so that we can use it. So it's a really, tight system. You can do all your data prep now, ETL, right in the data lakehouse, one copy of it, not having to do extracts or replication or anything like that, and then use it in all the workloads that you might have in your environment, right? And that's just, that's amazing. We've been waiting a long time in the industry for something. I'm very old, Chandra. I've been in the industry a long time. We've been waiting a long time to have a really integrated thing like this, where we could do all our workloads on one copy of the data. Let's see what else. So basically, that's mostly what I wanted to show you. There's also, of course, you can get at through AWS and all the rest. There's so much more I'd love to show you. Just don't have time. Hopefully this showed you how you can very quickly provision a data lakehouse and how it can handle, all your use cases, and that you can do it all with one copy of the data. One other thing I want to mention, we use SQL to do our data preparation, right? But sometimes there's data transformations or data preparation that you really can't do easily with SQL. It requires imperative code. And for example, that'd be like if you have complex string processing, or text or recursive or graph structures, or you're doing feature engineering. There's a lot of examples. And for that, Chandra's going to show you a new feature that we have that actually allows you to submit code right into the OneHouse ecosystem here. So I'll let Chandra take it away and show you that.
Of course. Thanks, Cameron. Super exciting. Thanks for the demo. I'm going to take over the screen share now. Sorry, you can flip it over to what I've got. Perfect. Thank you, guys. So yeah, as Cameron mentioned, this is something new that we've released inside of the OneHouse platform, is the ability to run Spark jobs directly on top of the compute that OneHouse is provisioning and managing. As we all know, Spark has kind of become a really powerful framework for doing data transformations. How many of you guys are out there kind of running Spark jobs right now on other platforms? Maybe you guys have some EMR Spark jobs, or maybe you're doing it in like GCP Dataproc or something like that. Drop in the comments, where if you guys are running Spark jobs, what are you guys using to run it right now? Maybe you're hosting it yourself, running it on Kubernetes or something like that. It's always an exciting infrastructure challenge to try to do something like that. What we want to do as a part of this is, if you have a Spark job that you're already running, or maybe you want to write a Spark job, but you want to take advantage of all of the accelerations that we have from our Quanton engine, from our Lakehouse integrations, and from the ability to maybe do table services and management and have that data interoperable across all of the different other tools in your ecosystem. That's kind of where this comes in. As a part of this, it's really straightforward. You kind of have your existing code somewhere. Maybe it's a PySpark job, or you've compiled a Java jar or something like that. Basically, what you do is you go in, you give the job a name, you specify, is it a jar, or do I have Python code here? And then you assign that to a compute cluster. So I'm going to go and let's say I've got a jar. I assign it to a compute cluster. And this is one of the compute clusters that Cameron mentioned earlier under the clusters tab here, where he created a cluster. One of the options is that you can create a Spark cluster. And so you go in, you create that Spark cluster, and it'll show up here as something that you can assign the job to. And then you just pass it your Spark submit args. The same arguments that you would give to any Spark submit, regardless of where you're running it. So you give it your class name, or your .py file, your Spark configs that you want it to run with, and you hit create job. I've already got a bunch of jobs created here, and I've got this one that I made for the conference demo, and so you can see I've got a jar here. That's specified. I gave it some configs. I'm using a lot of default Spark configs here, but I'm also passing some custom configs here around table path and things like that. It lets you see the past runs of the job, so I can say, oh, my last run failed. Let me go look. Why did it fail? I can go in and take a look at the the driver logs for the job, and I can say, oh, okay, it looks like I forgot to set my database, or I forgot to set defaults on the database for inside the job somewhere. So I can go back in, fix it, and rerun the job. I can also take a look at the Spark UI directly from here and start analyzing what's going on inside the job. What stage is it at, things like that. For me to run the job, it's as simple as going to this job here, hitting run, and having the job start to run. It takes a second for it to spin up the compute needed and provision resources from the compute cluster, and so it'll queue up, and then it'll be running, and it'll tell you, oh, did the job fail, did it succeed? If it fails, we'll let you know. We'll give you a notification as a part of the platform notifications. What you'll see here, though, is because my last run succeeded, what I do inside this jar is I read some downstream tables. I do some simple aggregations in there, and I write a new hoodie table. The really powerful thing is, because all of this is happening inside of the ecosystem here at OneHouse, that hoodie table that I'm writing as a part, and this hoodie table, by the way, it's writing to my S3 bucket, sitting in my AWS account. That hoodie table automatically gets synced up here. So under the data tab, I'm able to go in and I'm able to see OpenX data, my hoodie table here. This employees OpenX data table. It's basically some simple aggregations on top of some synthetic employee data. I can see the records. I've aggregated a lot, so it's only 5 records that are in there. But I get all the same rich metrics that come in from the stream captures and things like that Cameron showed you. I also get all of those table services, so I'm able to come in and automatically the OneHouse tool will realize, oh, okay, this is a hoodie table. I can run some table services on here. Let me try to sync it to the catalogs that are configured. And you can manually, edit this as well. Let me make sure the table's cleaned up. Let me make sure it's a merge on read table. I want to make sure the compaction service can run. Things like that kind of come in seamlessly through the platform. On top of all of these tables that are deployed on top of the jobs. All of this, want to come back, is built on top of our Quanton engine and the OneHouse compute runtime, where you're able to take advantage of performance accelerations. This is just an illustration that we saw from some sample customer workloads. Where because of the compute accelerations that we have inside of the platform, the infrastructure spend gets reduced pretty significantly. Again, this is kind of a theoretical illustration scenario, but we'll see that infrastructure spend go down, and you'll be able to really take advantage of some exciting cost performance benefits. That's kind of what we wanted to talk about for our workshop and what we wanted to show you guys. Wanted to quickly, thank you for sticking around a little bit longer and spending some time with Cameron and I. I know we enjoyed getting to show you guys all of this. There's lots of ways that we can continue to work together, between OneHouse and the use cases that you're running. As you saw today, we have pretty exciting capabilities across ingest, cost performance, table optimizations, keeping your data open, interoperable, available for the use cases that you want in your organizations. So definitely reach out. Got my email and Cameron's email right there. Let's stay in touch. And again, as Cameron said, if you want to get your hands on and try the product, let us know. Drop a comment here. Send one of us an email, and we'll work together to get you on and trying out the product and seeing what we're able to build with it together.
Do we have time for questions, Chandra?
I think we've got maybe a minute or two. Yeah.
I don't know if we have any. I can't see the questions here.
Well, I'm not able to see the questions either. If someone wants to, I know one of the hosts. You guys want to maybe let us know if there are questions.
Maybe not. Oh, here we go.
Demetrius.
He's coming back.
Work. You guys are making me work. My video is off, to be honest. It's very dark because. But the questions are so many. We've got a whole different platform that I'm going to give you all a link to so you can check them out. But basically, I'll drop in here a few. How do you, oh man. Given that queries seem to be much faster than writes, are there certain use cases you immediately think of for this technology?
Well, I mean, the big use case for the data lakehouse, I think, is just getting all of your data acquisition and data preparation off of the more platforms and into something that, to run, faster to run, do more things with fewer copies of the data. I mean, it's really a cost argument and an architectural argument. You're still going to have your platforms, that do specialized things for machine learning, data science, analytics, dashboarding, all that. You still got to do, analysis, but this just makes it so much more cost efficient. I don't know, Chandra, how would you add to that?
I think that there's tons of really exciting advantages. You highlighted a few of them. Some of the things I'd want to talk about are also around scale, right? These platforms, especially built around lake houses and the way we've been able to operate this at one house, get battle tested at some of the largest scales that we've seen out there, and so that's really exciting too. To see these platforms sing at scale is a rare thing, and something that it certainly gets me fired up.
Yeah, if you think about some of the, we're also dabbling with, doing vector embeddings for large language models, and you think about that, the data that you hold in the data lake house versus the amount of data you either can or would want to put platform, then it's a cost saving thing. So, it's not a question of, doing new things. It's a question of really offloading those specialized systems that are expensive and limited in terms of volume, and the data lakehouse being able to just handle more. I did see a question about it being on-prem or in the cloud, and I just want to mention that no, this is completely a cloud thing. And if you think about what I did with being able to pick up the data from Databricks or Snowflake, dashboard and superset, and then using DBT Cloud, it all needs to be in the cloud, right? That's how you and integrate all these different workloads. So no, it's cloud only.
Yeah, definitely. And Hamid, I think you asked that question. If you've got use cases, let's chat afterwards. Let's get in touch and we can chat about how you might want to think about this from that standpoint, cloud versus on-prem type things. Michael, I know you've got some questions around cost and speed and accelerations. We can take this offline and connect one-on-one as well, but there's a whole variety of ways that we see performance accelerations on these jobs. Most recently, we actually launched. If you're running Spark jobs, I'll see if I can drop a link to our most recent blog here. But we at the end of this blog. At the end of this blog here, you'll see that there's actually a workload cost calculator. So some benchmarks here in this blog, and then in this blog you'll find a cost kind of predictor where we're able to go in and estimate for you how much we think that the one house, Quanton engine might be able to speed up your workload across, the extract, load, transform phases of it. And so definitely something to check out. You'll see it directly in our homepage right on the blogs. And so, yeah, feel free to fill out the form there, and it should give you back some results on what we think our performance accelerations could do for you.
So I'm seeing just sort of random questions popping up here. Somebody asked, does it have data quality built in? Yeah, inside data validations to the data coming in. Remember, you can move those records that don't pass the validation over to the quarantine table, so you can deal with them later. But the real beauty of this is really you could plug in any third-party data quality solution. Data is so open. Just like I was preparing data with whatever industry-specific customer management system, you could actually plug that in. So it's very, very flexible that way. Some of these questions I just can't understand what they're asking. Somebody asked, what software do you think are most important for me to dive into?
I think you're on the right track right now. You've got a lot of good experience across SQL, Python, on the data visualization side. Would love to have you, start taking a look at some Spark capabilities and seeing how Spark can help out on there, David. That would be really exciting, especially as
I think data.
Yeah.
I think in addition to all this, quite often people that can really put a system together. Of course, we're making it. This even the notion of using a data lakehouse is still new to people. This architect, bringing this up. A lot of people, we're just going to throw our data in a database or whatever. They don't really think about using a data lakehouse and getting the scale and efficiency and cost reduction and just the openness that we can provide. So I think that's a good thing to consider as well.
Yeah, definitely. Perfect. I know we're a little over time here, so we want to
send us our emails so we have them up. But yes.
Yeah, certainly. Well, thank you everyone for sticking around for a little bit. I know we had a lot of fun, as I said earlier. So thanks for hanging around, and looking forward to hearing from all of you and staying in touch.
Thanks, y'all. Thanks, Chandra.
Right.
Take care.
Bye-bye.